হ্যালো, কি হলো? হ্যালো শুভম,
হ্যাঁ স্যার বলুন।
কি আমার নামটা এরকম হয়ে গেছে কেন? খুব
হ্যাঁ
গরম ভালো।
হ্যাঁ, আমি সেটাই বলছি। আমি তখন দেখেছিলাম খুব গরম ভালো বলে, এইবার সেই কারণে।
ঠিক আছে। হ্যাঁ, আমি তো আমার তো ইয়েই নেই, তোমার জুমে তো আমার ইউজার আইডি পাসওয়ার্ডই নেই।
হ্যাঁ কি, দাঁড়ান আপনাকে রিনেম করে দেওয়া যায় হয়তো, দাঁড়ান আমি করে দিচ্ছি রিনেমটা।
আমি তো জুম কোনোদিন নিজে থেকে ইউজই করিনি, আর তাও আমার ইনস্টল নেই। তো আমি তো ইয়ে থেকে চালালাম, ব্রাউজার থেকে চালালাম।
হ্যাঁ খুব গরম ভালো হয়ে রয়েছে, সেই জন্য বুঝতে।
এসব অদ্ভুত ব্যাপার।
হ্যাঁ
এই
এবার
তো।
আমি চেঞ্জ করে দিলাম স্যার।
হ্যাঁ হ্যাঁ হ্যাঁ, তার মানে ওখান থেকে কিছুটা হয়েছে।
আমি চেঞ্জ করে দিলাম এই জন্য
ওকে,
যে
ঠিক আছে।
রিনেমের অপশন দেখালো। আপনাকে কি হোস্ট করে দেবো নাকি?
আমাকে প্রেজেন্টেশন দিতে হবে, ঠিক
হ্যাঁ হ্যাঁ
আছে।
হ্যাঁ, আমি খুলে
তো
দিয়েছি,
দাঁড়া,
আপনি
আমি
দিতে পারবেন, কোনো
আচ্ছা,
অসুবিধা নেই।
দেখে নিচ্ছি 1 মিনিট।
আপনি শেয়ার করুন স্ক্রিন, আমি দেখে বলে দিতে পারবো।
দাঁড়াও দাঁড়াও, সব আমি করে নিচ্ছি একবার। ও, স্ক্রিনটা শেয়ার করতে হবে না আগে। Share the screen. দেখো
হ্যাঁ
তো
স্যার,
গেছে কিনা।
হ্যাঁ 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 দেখা যাচ্ছে, এই তো ডেটা স্ট্রাকচার বলে দেখা যাচ্ছে, অসুবিধা নেই।
আচ্ছা, ওকে। দাঁড়াও, আরেকটা জিনিস আমি দেখে নিই চ্যাট করে। সেটা হচ্ছে আমার এই পেনটা কাজ করছে কিনা।
হ্যাঁ
হ্যাঁ, এই ডিভাইসটা
হ্যাঁ
আগে কখনো ইউজ
দেখা
করি।
যাচ্ছে।
ঠিক আছে। Stop sharing.
স্যার একটু ওয়েট করুন, আমি বলে দিয়েছি অলরেডি সবাইকে
হুম,
জয়েন করছে।
স্টুডেন্টরা তো নেই মনে হয়, নেই ক্যাম্পাসে।
না স্টুডেন্ট আর নেই স্যার ক্যাম্পাসে।
স্ক্রিনটা শেয়ার করাই আছে তো?
হুম হুম হুম, স্ক্রিন শেয়ার করা আছে, আপনি করতে পারবেন, কোনো অসুবিধা নেই।
আচ্ছা।
স্যার একটু ওয়েট করুন, বাকিদের ইনফর্ম করে
ঠিক
দিয়েছি।
ঠিক ঠিক আছে, ঠিক আছে। আমার কথা ঠিকঠাক শোনা যাচ্ছে তো?
হ্যাঁ 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 হ্যাঁ, আপনার কথা
হ্যাঁ।
মানে একদম ক্লিয়ারলি শোনা যাচ্ছে।
তোমাদের কোয়ার্টারও কি কারেন্ট ফারেন্ট নেই নাকি তাহলে? কোন ব্যাংক?
Everyone, please mute yourself. Jai Prakash Kumar, Shivam Kumar. Okay. So, good morning to everyone. Welcome, everyone. Thank you for joining us today's webinar. My name is Shubham Chakraborty, and I am the host for today's webinar organized by Computer Science Engineering Department of Chaibasha Engineering College. Today, we are presenting TCube3 sponsored 5-day special classes on data structure presented by Dr. Animesh Datta, eminent associate professor from NIT Durgapur. He has completed his PhD from Jadavpur University. His research areas are semantic web ontology engineering, big data and social network analysis, multi-agent system. He has been awarded a lot of awards, and among those, some worth mentioning are ASEM DO Professor Fellowship 2020, Vishishwara Young Faculty Research Fellowship Award. Just a little housekeeping before we get started. If uh, you have any question during the presentation, you type them into the question box in your Zoom control panel. I will bring them up during the presentation, and we will also have the time for questions at the end. Now, without further delay, we will turn the time over to our presenter today, Dr. Animesh Datta sir. Sir, are you here?
Yeah, I'm here.
Okay.
Thank you, Shubham. So let us start the presentation, today's presentation. So good morning, everybody. So my lecture plan and whatever I have, I will briefly discuss the plan of the lecture, the objective of the lecture. So I think all of you are from third semester. So based on that, I mean, whatever I got the information from Shubham that all are you from third semester. So accordingly, I made some kind of presentation and the content of the entire talk. So gradually I will be discussing everything. And after the initial discussion of the course overview, if you have any special requirement for particular topic or in depth of a particular area of the data structure or algorithm kind of thing, then I will be going to the more detail about that thing. Because we have 5 days. So initially I will give the just brief overview with a few slides. Then I will be going to the actual content of the presentation. So as the second thing is, as the number of students is very less, so I will request everybody that if possible, we can make it interactive. Even instead of waiting for the end of the presentation, if you have queries, you raise the queries on the way, we will discuss online even, such that everybody can participate in the discussion. Okay. So the main topic is data structure, and the objective of the course to be familiar with the problem solving approach of computer science and be able to develop and implement the algorithm. be able to trace the algorithm. That means you are designing an algorithm for a particular purpose. You have certain input, you have certain output. Now, based on the input, what output you can expect, that is called the tracing. So you have certain input, you are writing some kind of computation, the processing of the algorithm, and you are expecting some kind of output. So here you see you have some specification for the input, that maybe list of integer. So it is a specification of the input. You have the certain specification of the output. For example, the sorted in the ascending order or sorting in the descending order. So that is a specification of the output. So as a designer of the algorithm, you need to trace that this is my input and this is my output that I am expecting. The fourth is able to select appropriate data structure and algorithm for a given problem. Now, you are planning to design an algorithm. For the particular algorithm, you have certain set of input. The input can be a simple data, or it can be a collection of data with some relationship among the data. So what type of data structure, that means what type of data and their connectivity will be there, that as a designer you need to choose. So in this course, we will also discuss what data structure you should choose to design a particular algorithm for a given problem. So the outline of the course is the fundamentals of data structure and algorithm, static and dynamic data structure, basic searching and sorting of the algorithms, the basic functions and recursive functions. Then I will be going to the abstract data type. What is abstract data type? Some example of abstract data type, how abstract data type is normally different from traditional data. Then some of the abstract data type, for example, stack queues and their operation, their implementation in different perspective. Next, another abstract data type is kind of trees, where we'll be focusing. So this is the brief overview, brief outline of the course that I have planned, because based on the third semester concept, I have designed this brief outline of the presentation, and in the gradually all the session, maybe tomorrow, to day after tomorrow, and all till Saturday, we will be discussing based on this topic. So if you have, if you student have any specific requirement for a particular algorithm or particular technique or particular sorting algorithm or searching algorithm kind of thing, you may ask for that. I will try to solve your problem as much as possible. Now, what is data? Data is a collection of facts. Data is a collection of facts. Data is a collection of facts which conclusion may be drawn. For example, we can say there are 10 students. So 10 students is a data. The name of the course is data structure, is a data. Name of your college, Chaivas Engineering College, is a data. Is a data. Today's temperature is 25 degrees centigrade. Is a data. From there you can conclude. Shubham, would you please request to mute the mic of the student? Hello, Shubham.
Yes, sir.
Would you please request your student to
yes.
mute the mic? Otherwise, it will be a disturbance.
Everyone, please mute yourself.
Or I think as a host, you can mute their mic as well.
Okay, sir.
So a collection of, so a data means a collection of facts from which you can draw some kind of conclusion. I'm saying there are 10 students attending my course. So from there, I can conclude something. Today's temperature is 35 degrees centigrade. So from there, I can conclude whether it is hot or it's cold. So there can be different types of data that we normally use for our program. It can be a textual data. It can be some numeric data. Within numeric, you can have integer, float, long. There are a lot of types depending on the compiler you are using or depending on the programming language you are using. So that will be the different type of data. It can be audio data. It can be video data, many more. Now, what is data structure? So we discussed data. Now we'll be discussing data structure. It is a particular way of storing and organizing data in a computer so that it can be used efficiently and effectively. These two terms is very important, the efficiently and effectively. A particular way of storing and organizing your data in a computer system so that it can be used efficiently and effectively. What do you mean by efficiency and effectiveness of a computer system? See, we are always looking for faster computer. What is the size, what is the speed of your processor? What is the clock speed of your processor? We always look for that. That means we want to understand the speedness of your system. We always looking for higher speed. That means we submit a task and the task, how much time it takes to complete the task. That is called efficiency of the computer. That means it is the speed at which it can execute the instruction. Similarly, effectively, another term is associated with that. When you submit a program, how much memory it is asking for, whether your 4 GB RAM or 8 GB RAM is sufficient to execute the program. So that means one is processing power, the computer processing power, the processor. The other way is the memory capacity. So if you, for a particular program, if you choose a very complex data structure, that data structure may require a huge memory, which you may not have. So that means choosing the data structure is, of course, one of the parameters to write an effective program, which can be efficiently executed by your system. So what is data structure? A particular way of storing and organizing data in a computer so that it can be used efficiently and effectively. Next. A data structure is a logical or mathematical model of a particular organization of data. You define a structure of student that composed of first name, last name, age, date of birth, section, branch, year, maybe address. So they may have a different component of the whole data structure. You may define the whole as a structure with the name student that composed of number of primitives, types of data. For example, age can be integer type. First name, last name can be of your character string. Address can be your character string or alphanumeric kind of thing. So this way you can represent your data structure. Now, how to store the data structure? That means if you consider there are 60 students in a class, and each student consists of that structure composed of age, name, maybe registration number, hostel ID, etc., etc. So each of these structure you can keep in an array of size 60. So there are 60 students, so you define an array of size 60, and each array element is the information of a particular student. You can keep it. Why you are keeping all this information of the 60 student in an array? Array is a data structure, and that gives you the feelings of logical and mathematical model. Why? It can give you some logical, you can execute something. For example, you can search the array for a particular student. You can search the student person with a particular registration number or particular roll number or a particular branch of student. Once the student left, you can delete that data. Now, if you use the array, you may have some pros and cons. There can be vis-a-vis other data structure which can also implement the same purpose. So you have to choose which data structure you will be using for your purpose. Okay. Second is a group of data elements grouped together under one name. For example, as I said, array of integer. So array of student information. There are 60 students. Each student composed of number of small primitives data. For example, name is a character string, age is an integer, etc., etc. So each student composed of a structure. This way, you are keeping the information of 60 students, and all the 60 students are kept in an array of size 60. So array of structure. You want to keep the marks of 60 students. So array of integer. Now, there are different types of data structure that we normally use. Some of the basic data structure that we use in computer in the 3rd semester or 4th semester are array, linked list, tree, queue, stack. There are many more other data structure, or using this data structure, you can make some more complex data structure. So these are the very basic data structure that we normally use. And even in this course of this 5 days course, we will be discussing these data structures with their algorithms, pseudocode, some operations, and of course, some code also. What is the need for data structure? To organize data. The need for data structure to organize the data in a computer memory such that computer can use it effectively and efficiently, that I said. Now, criteria to facilitate efficient. It is storage of data, retrieval of data, manipulation of data. As I said, you want to store the information of 60 students. So storage of data. Retrieval of data. You want to retrieve the information of one student having the name this, or you want to retrieve the student having the registration number this. You want to manipulate the data. That means you may change someone's address or CGPA or maybe branch. So that means you can upgrade the data. Design issues, select and design an appropriate data types. There is the main motivation to learn, understand data structure. This is the main, which data structure you will choose for your particular algorithm or to solve your particular problem. Now, some of the basic operations on the data structure. traversing. You want to traverse the entire data structure. If you don't know the advanced data structure like linked list or array or linked list or tree or something like that, even you take the very basic data structure is the array. You can traverse it. Once you know the address of the first node, first element, you can traverse the entire array to get the actual information. So maybe there are 60 students, information of 60 students kept in an array, and you know the base address of the array. So just by traversing, you can go to any particular location of the array. You can search the entire array, finding the location of the particular data element, which can be called as a key. Which can be called as a key. For example, you are looking for a student having the name this. So there are 60 students. There are 60 students. There are 60 students, and you want to find out the person whose name is maybe XYZ. So XYZ is a key in the structure. Next is adding a new data element to the structure. You have an array and you want to insert a new element. Where will you add? There are options. You can add the element at the end of the array. You can add the element in its proper position. The position can be the ascending order, maybe the descending order, the alphabetical order, or whatever. So choosing a particular type of operations, you can insert that particular element in the structure. Next, you have a large data structure. You want to delete a particular node. From an array of 60 students, you want to delete some 2 students. Maybe they left the institute. So you want to delete. So from the 60 students, you want to delete. So while you're going for the deletion operation, first you need to search that particular 2 students. So first you have to search the student, then you have to delete it. So removing a data from the data structure. Next is your sorting. Arrange the data elements in a logical order. Maybe you want to sort them in the order of their CGPA. You want to sort them in the order of their date of birth. You want to sort them in the order of their first name. So this can be ascending order. It can be descending order. So based on this sorting idea, we will be discussing some algorithms for sorting technique. Next is your merging. You have 2 data structure of the same type. Maybe there are 2 arrays. One array composed of 60 students, another array composed of 30 students, and you want to merge them. Maybe you can directly merge them. So the second array may be connected with the end of the first array. And your requirement can be much more of that. What can be the requirement? After merging, this should be in a sorted order, maybe ascending order or descending order of their name, or maybe in the order of their CGPA. So combining data elements from 2 or more data structure into one. The next we will be discussing what is algorithm, because during this course, along with the data structure, we will be discussing some basic algorithms and how to write the algorithms for some of the operations that we will be discussing. So what is an algorithm? A finite set of instructions which accomplish a particular task. So set of instruction written in any language, mind it. Set of instruction written in any language which can take something as input. It can execute or the process. As a result, it produces some output. So an algorithm composed of mainly 3 parts: input, processing, and output. So an algorithm will have an input section from where it takes some input from the user. It starts executing So that means it has some executable instruction, maybe written in some language. It may be Hindi, it may be Bengali, it may be English, whatever. You don't have any botheration of the language while writing the algorithm. It produces the output. And mind it, while taking the input and producing the output, this should be a finite time. Finite time. That means you can count the time. It cannot be infinite time. Within a finite time, we will get the output, starting from the input to produce the output. So sometimes it is called algorithm development is an art. It needs practice and practice and only practice. So you have to do a lot of practice to develop an algorithm. And as a computer science student, you should develop that art in yourself. Because in wherever you work, you may be working in software design, you may be working as an algorithm design, you may be working in network, you may be working in security, wherever you work, everywhere there's an associated of lot of algorithms. Now, what is a good algorithm? There are some properties with which you can say it is a good algorithm. It must be correct. What do you mean by correct? Correct means it has some input, or it can take some input. And as a designer, you are expecting some output. Okay, so from input, there is a processing and output. So it should produce the correct output based on the input that you are giving. Then you will say it is a correct algorithm. It must be finite in terms of time and size. That means the number of instructions in the algorithm should be finite in size. Maybe 10 instruction, 20 instruction, 1000 instruction, 2000 instruction, but should have a finite number of instruction. In terms of time, as I said in the earlier slide, that it should complete in finite time. It should not execute in infinite time. That must be some terminating condition. Maybe after this execution, it will be terminated, or after getting this condition, it will be terminated. And that termination point will come in a finite time, maybe 2 minutes, 3 minutes, half an hour, 1 hour kind of thing, which you can count. It must be unambiguous. What do you mean by that? It means after a particular instruction, what will be the next instruction? That should be clearly written and should be understandable by anyone. That means you may be a very good algorithm designer. You design the algorithm, but you may not write the code for the algorithm. So you are working in a team in a software company. So you as a designer, you develop the algorithm. Another person who is a coding expert, who will write the algorithm, who will write the code of the algorithm, maybe in Python or C or Java, whatever. So that person will be using your algorithm as the input for writing the code. So that's why your algorithm should be unambiguous. Otherwise, the coder who will be writing or developing the code cannot understand what you have written. It must be space and time efficient. Space means typically we use the space means the memory unit it requires for for executing your program based on the algorithm that you have developed. How much memory it requires to execute the program? Maybe it requires 2 GB, 4 GB, or 8 GB, or 32 GB, whatever. So the lesser it requires, the better it is. So that means you can execute your program with less memory. You don't require much memory. Then your program is a very good program. Time efficient. How much time it requires to execute the complete program. Or we can say time complexity. How much time it requires to complete the execution of the program or the algorithm. So that's why a program is an instance of an algorithm written in some specific programming language. A program is a set of instructions written in a programming language for a particular algorithm. So you have written an algorithm for a particular purpose, and somebody is writing the code, the program for it. The program can be written in any programming language. It can be C, it can be Java, it can be Python. Whatever programming language you are comfortable with, you can use that to write the program. Next, the question is, how do you write the algorithm? A simple algorithm, all of you are familiar, I think. There are three numbers, A, B, C. You have to find the maximum of these three. So you have three elements, A, B, C. They are all numeric values. Your objective is to find out the maximum of it. So here you see the output is the input is these three elements, A, B, and C. Output is the maximum value of it. So this is my input, this is my output, this is my processing. So we are writing the instructions in simple English-like language. Let max equal to A. If B equal to max and B greater than max, then max will be B. If C greater than max, then max will be C, and display max. So this is the basically you are putting the output. You're putting the output. The question is, can you trace the algorithm? That means the input you are giving, and based on that input, what output you are expecting, are you getting the same output? Based on the input, the output that you are expecting, are you really getting that output? If yes, your algorithm is correct. Is the number of instructions in this algorithm are finite? That means, can you count the number of instruction in the algorithm? So here 1, 2, 3, 4, 5, 6. There are 6 instructions. So obviously it is finite. Finite in size. Are you getting the output in a finite time, or is it going to an infinite loop? You are getting the output in a finite time. Once it reaches this condition, it will display the output. So this way you can check the algorithm. So here you see we have written this instruction not in a particular language or not in the basis of